Hey guys, this is a walkthrough of the beginning of Unit 6. So this is lesson 6.1-6.2, which we're actually just labeling as 6.1. So the first thing we have is this picture. It says cell phones often indicate the strength of a cell phone service with a series of bars. Let's look at the following pattern. So we have figure 1 has 1 square. And I always like to write how many of something there are through a whole thing just to visualize the numbers better. Figure 2 has 3 squares. Figure 3 has 6 squares, and figure 4 has 10. So another thing I notice about it is figure 1 is this 1 by 1 square. Figure 2 has 2 at the bottom, 2 going up. Figure 3, 3 at the bottom, 3 going up. 4, 4 at the bottom, 4 going up. So when I draw the next figure, which is what number 1 is telling us to do, I know that I'm going to have 5 at the bottom, and 5 going up. So then I'm going to follow the shape of this the rest of the way through. And then it gives it that cell phone tower kind of, or cell phone strength kind of look. So there's figure 5. Which has 15 blocks. So it says, how many blocks would figure 10 have? And draw it. So based on that same pattern I said where figure 1 is a 1 by 1, figure 2 has 2 at the bottom, 2 going up, 3 at the bottom, 3 going up for figure 3, and we kept following that pattern, we could draw figure 10 pretty easily. So I'm going to try to use this whole space. So I have 1, 2, 3, 4, 5, 6, 7, 10. There we go. And I want it 10 going up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then follow that same shape as the rest of the figures. So I'm going to count it just to make sure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is figure 10. And you could sit here and count all this out, or I can just give it to you that this is 55 blocks. All right, so it says create a table of the pattern. So we know that in figure 1, there was 1 square. In figure 2, there were 3 squares. In figure 3, there were 6 squares. 4 is 10. 5 is 15. And if we continued the same pattern, 6, 7, 8, 9, 10, and then we're going to call it n. So we would have 21 in that one, 28 in this one, 36 in this one, 45, and 55. And the way I think about this is each time it's like we're adding another row at the bottom. And that's how I made my table a little bit easier. So I have this one that shows up every single time. And then I have these 2 that appeared in figure 2. And then I have 3 more that appeared in figure 3. And 4 more in figure 4. So I just kept adding another bottom row that matched the number of figures. So When it comes to quadratics, because this is the beginning of our quadratics unit, the way to know if something is quadratic is because they have the same second difference. So what on earth is the second difference? So the first thing we need to do to make sure it's not linear is find the first difference. So we know to go from 1 to 3, we add 2. To go from 3 to 6, we add 3, add 4. 10 to 15 is add 5. And our pattern follows the whole way down. So we have 36 to 45 is add 9. From 45 to 50 is add 10. So those are your first differences. And we're going to label it that way. So first difference. So the second difference is how you know if it's quadratic. So far we notice it does not have a constant rate of change. We're not adding the same thing over and over again. But if we look at the second difference, to go from 2 to 3, we add 1. 3 to 4, add 1. 4 to 5, add 1. 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10. You're adding 1 the whole way down. So that's the pattern that we can see in this table. So over here on the right, it says, looking at the table to the left, is there a pattern that you see? And words describe what's happening to get to the next picture. For example, if you want to draw out 154 pictures, or do you want to draw out 154 pictures to get to the 154th image? No. Nobody has time for that. So we have to come up with some kind of formula to help us figure this out. So if we wanted to explain this basically, we could say that you add the figure number to the previous amount. That would be like our recursive formula. So add, and I'm going to put that in blue because it goes with my blue explanation. So add figure number to previous amount. That's like the recursive formula. But there has to be another way, and that's what we're going to explore as we go through this unit. So these are quadratic, and I wanted to show you guys that they have the same second difference, and that's what makes it quadratic. So I'm going to put quadratic because the second difference is constant. And I'm not going to make you guys write the formula for this one. Not yet. We'll get there. This is kind of our first step in the stair steps that take you to this pattern. If you guys want to spend some time trying to figure it out, that's fine, but we're not going to do that at this point in the unit. At this point in the unit, we are simply discovering the patterns. So next we have this page. So we have figure 1 has 5 squares. Figure 2 has 8 squares. Figure 3 has 13 squares. And if we look at these, we can actually see a little bit of a pattern. In figure 1, there's a 1 by 1 square in the middle, just one square. In figure 2, we have a 2 by 2. In figure 3, we have a 3 by 3. So another way that we could write this is in figure 1, we have a 1 by 1 plus 4 more. In figure 2, we have a 2 by 2 plus 4 more. In figure 3, we have a 3 by 3 plus 4 more. So if I tell you that the figure number is represented by the variable x, we have 1 times itself, 1 squared plus 4, 2 squared plus 4, 3 squared plus 4 is figure 3. So it's your figure number squared plus 4 would give you all of the numbers to fill this table. So for 4, 4 squared is 16 plus 4 is 20. For 5, 5 squared is 25 plus 4 is 29. For 6, 6 squared is 36 plus 4 is 40. For 7, 7 squared is 49 plus 4 is 53. 8 squared is 64 plus 4 is 68. 9 squared is 81 plus 4 is 85. So sometimes when you have these perfect squares in your image, so there was 1 in the middle, and then a 2 by 2 in the middle for figure 2, and a 3 by 3 in the middle of figure 3, you can see those patterns. So our next one is a little bit different because in figure 1, we have a 2 by 2. In figure 2, we have a 3 by 3. In figure 3, we have a 4 by 4. So every time we're talking about this figure number, the square that is formed is 1 bigger than the figure number. So figure 1 has a 2 by 2. Figure 2 has a 3 by 3. So that's how we created our square. And then in every single one of them, they have this little blue square off to the side, that 1 extra. So we're going to add that 1 extra. So when we fill in our table, we can use our formula or we can use our pictures. So figure 1, we see 5. Figure 2, there's a 3 by 3, which is 9, plus 1 is 10. In figure 4, there's a 4 by 4, which is 16, plus 1 makes 17. So for the rest, you could plug straight into your formula we created by recognizing the patterns in our shapes. So we have 4 plus 1 is 5. 5 squared is 25 plus 1 is 26. 5, so we're plugging in 5 for x. 5 plus 1 is 6. 6 squared is 36 plus 1 is 37. 6 plus 1 is 7. 7 squared is 49, plus 1 is 50, and I'll let you guys fill in the last 3 values and check it on Canvas on your own. So our next one, we're going to call this figure 1, 2, 3, 4, 5, because it's not marked. So in figure 1, there's 1. In figure 2, there's 5. Figure 3, there's 9. Figure 4, there's 13. Now, if we look at the colors on these, we have that 1 yellow dot in the middle that appears in all of them. And then we add 4 dots, 4 green dots, and it appears in all of them. Then we add 4 more dots that are red, and it appears in all of them. Then for figure 4, we add 4 blue dots. So in this one, we're adding 4 every time. We're not drawing these perfect squares in order to make a variable squared. In this case, we're just adding 4. So our pattern is adding 4, which makes it linear. And I'm going to put because add 4. So we could finish filling in our table. 21 plus 4 is 25, plus 4 is 29, plus 4 is 33. So we could actually write this one as well. So we have, you can write this one of 2 ways. You can use your first term just like we did back when we did sequences, where you would end up with y equals your first term plus your rate of change times x minus 1. Or you could backtrack and find that zero amount, that imaginary zero amount. So if we're adding 4 going to the right, we would subtract 4 going to the left, and 1 minus 4 is negative 3. So when we write this, we can have a rate of change of 4 and a y-intercept of negative 3. If you simplified this equation, you would get the slope-intercept form y equals 4x minus 3. In this next section, I'm going to choose 3 problems for us to go over. It says for each of the tables below, look at the y value column or row. Find the difference. Then, if needed, find the second difference. Based on that information, label them as linear, exponential, or quadratic. So linear, rate of change is constant. You're adding the same thing every time. So add, actually, we should probably put the first difference. So first difference is constant. That's linear. Quadratic, the second difference is constant. With exponential, it's multiplying to get through a table. So from one y value to the next, it will be multiplication. Okay, so when we go through this, we're going to do the first one together. So we have, to get from 24 to 6, we subtract 18. To get from 6 to 0, we subtract 6. To get from 0 to 6, we add 6. 6 to 24, add 18. 24 to 50 is add 30. So we automatically see that this is not multiplying by something, because 0 times anything would give you 0. So if there's a 0 in the y column, it cannot be multiplication unless it's all zeros. And then it's not exponential anyway. So exponential is out. Linear is out because those first differences are not the same. So we have to find the second difference. To get from negative 18 to negative 6, you add 12. To get from negative 6 to positive 6, you add 12. 6 to 18, add 12. 18 to 30, add 12. So this one is quadratic because it has a constant second difference. So the next one I want to do is this one. So from negative 5 to negative 2, we add 3. Negative 2 to positive 1, add 3. 1 to 4, add 3. 4 to 7, add 3. 7 to 10, add 3. We don't even have to go any further because the first difference is constant, which makes it linear. The last one I want to do, if I look at this, I see that the difference between half and 1 is I'm adding half. 1 to 2, I'm adding 1. 2 to 4, I add 2. 4 to 8, add 4. 8 to 16, add 8. If you did your second difference, you would have add half, add 1, add 2. So there has to be another way. So instead, we could also look at this as 2 halves makes 1 whole. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So in this one, you're multiplying by 2. So it is exponential. So I want you guys to fill in the rest of these tables and see if you can find whether it's linear, exponential, or quadratic.